Light is an energy that is emitted by accelerating charges. They are often the electrons in atoms. The energy that travels in a wave is partly electric and partly magnetic, meaning that it is an electromagnetic wave. The waves in light are transverse waves, so the motion of the particles is perpendicular to the motion of the wave.
Physics is clearly seen in an electric fan. The electricity routed through the mechanics of the fan produces the movement of the fan blades in a rotational movement. While it consumes a lot of energy, it rotates, generating kinetic energy, which is the energy that an object possesses due to its motion.
Newton's third law states that for every action, there is an equal and opposite reaction. The size of the forces on the first object equals the size of the force on the second object. As you walk, your feet are pushing against the floor and the floor pushes back on your feet as a reaction.
Sound waves are produced by a vibrating object. The speakers are vibrating as a song is being played loudly in the room. These sound waves can be heard by the average human ear with frequencies from as low as 20 Hz and as high as 20,000 Hz. Amplitude determines the intensity of the sound. The higher the amplitude, the higher the intensity of the sound.
Work done on the charge is equivalent to the electrical potential energy change of the charge. Thus, electrical power, like mechanical power, is the rate at which work is done. Like current, power is a rate quantity. Its mathematical formula is expressed on a per-time basis. The unit of electrical power is watt. A watt of power is equivalent to 1 joule per second.
Newton's first law, also known as law of inertia, states that an object at rest stays at rest and an object in motion stays in motion with the same speed and same direction unless acted upon by an unbalanced force. Objects tend to keep on doing what they're doing. In fact, it is the natural tendency of objects to resist changes in their state of motion. This tendency to resist changes in their state of motion is described as inertia. When you stir a drink in a cup and stop, the swirling continues due to inertia.
Microwave heating is largely caused by the changing electric and magnetic fields which are emitted by your microwave oven affecting polar molecules. Microwaves turn electricity into heat by the microwave generator, called the magnetron, taking electricity from the power outlet and converting it into 12 cm radio waves. The microwaves bounce back and forth off the reflective metal walls. The radio waves penetrate inside the food, and as they travel through it, they make the molecules inside vibrate more quickly. The faster the molecules vibrate, the hotter the food becomes.
Shaking this bottle of sriracha sauce displays the law of inertia, or Newton's first law. When bringing the bottom down and then suddenly stopping it, inertia is what causes the sriracha to come out of the bottle. The tendency of an object to resist changes in its state of motion varies with mass. Mass is that quantity that is solely dependent upon the inertia of an object. A more massive object has a greater tendency to resist changes in its state of motion.
Boyle's law states, for a constant number of molecules of gas at a constant temperature, the product of pressure and volume is constant. According to Boyle's law, when you shake a can of soda, small gas bubbles move towards the sides and the bottom of the can. Shaking the can causes the carbon dioxide to increase in kinetic energy. When the beverage is open, the pressure inside decreases. This causes the gas bubbles along the sides and the bottom of the can to elongate, which creates the mess of fizz in the top of the can.
Jumping is a major component in the physics behind basketball. When a basketball player jumps in the air to make a shot, he can be suspended in midair during the high point of the jump. This is a consequence of projectile motion. The higher he jumps, the higher the hang time. The trajectory path when shooting a basketball is very significant. The ball is acted on by acceleration due to gravity, which is 9.8 meters per second. There is a horizontal axis to show projectile motion, also known as x-axis. The axis represents the distance the basketball travels, which increases over time.
When playing basketball, practicing to dribble is very important. Oftentimes, people dribble the ball too quickly and they become out of control, or the ball hits their feet and bounces off. The speed in which you are dribbling is important to consider. By using the speed formula, speed equals distance over time, you can find your speed while dribbling. Energy is important when dribbling because it is what makes the ball accelerate downwards and upwards. As the ball heads back towards the player's hand, it gains potential energy. When your hand adds additional downward force, it then creates kinetic energy.
She see money all around me. I look like I'm the man. Yeah, but I was down and out like last week. Tell me, where have you been? You came out of hiding, girl. Don't act like I'm your man. You just a fan. You don't hold ring. No, 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 no. Don't hold no ring. Yeah. She see money all around me.
Okay, hey guys, welcome to our physics video. My hair's getting my face now. We just finished filming this part, so the fan feels really good, so we're just like chilling right now. But we have a couple more things to film, and I'm really proud of what we have so far. I feel like we just filmed a movie. So yeah, hope you guys enjoyed. Peace out. Put your hand in the face. Put your hand in the camera.
I look like I'm the man. Yeah, but I was down and out like last week. Tell me, where have you been?